type of motion, jenis-jenis pergerakan. Okay, basically we can divide type of motion into three. In general, it will be linear motion, it will be angular motion, and the combination of those two becoming general motion. Tiga. Okay, tiga. Alright. So let's move to the first slide. Okay. Form of motion. Human motion, most of it is actually general. Okay, which is a combination of linear and angular motion. Okay, both linear and angular motion is a form of motion which is useful to break complex movement down when performing analysis. This is why we need to know the type of motion, because if the motion is linear and then the analysis will be fall underneath linear kinematics and kinetics. Same goes as angular. The general sekaligus tak ada, kita kena pecah motion. Okay. So what is actually general motion is something like this. Okay, kita ambil satu contoh pergerakan manusia simple. Let's take what we call it walking. Okay, let's take walking. Okay, when we talk about walking, we are going to see a movement forward. Okay, daripada point A ke point B. We are going to see something like this. Pergerakan daripada point A to point B, or we call it as a translation. Pergerakan berubah tempat, translate. Okay, from one point to one point. But in order for human to actually move, kita kena ada rotation dekat sini, betul tak? We are going to have rotation at our hips, we are going to have rotation at our knee, we are going to have rotation at our ankle, dorsiflexion, plantar flexion, we are going to have rotation at hip. All of this rotation is known as angular motion. Ni secara keseluruhan tu angular motion. Translation from one place to another is linear motion. Okay, so combining both linear motion and angular motion, it becomes general motion. So in human, most of our motion is actually general motion. Kita tak boleh cakap gerakan kita totally linear, because for us to actually have a motion, we need to use joint. Jadi motion manusia ni dia akan bermula macam ni. We have stimulus, signal lah, stimulus to move, and then we have muscular contraction. Okay, after muscular contraction, we have joint movement. And then we have skeletal movement. And finally, barulah kita akan nampak total body movement. So this part, we cannot neglect this one. And this part involve purely in terms of angular motion. Jadi tak cakap macam mana pun, human motion is an example of general, because it involve both linear dengan angular. Okay, kita kembali kepada sini. Alright. So general motion is a type of motion involving both translation and rotation. Translation linear, rotation angular. Macam example yang ni, bola rugby yang kita throw dia forward, or we kick a rugby ball forward, which we can see the rugby ball travel forward at the same time the rugby ball rotate. Macam bola lah, macam bola sepak kan. bila kita nak buat curve ball. When we go for a curve ball in bola sepak, okay, we apply force which cause the ball to rotate and then it cause the ball to travel forward. Ni point A, ni point B. Nampak tak? Satu pergerakan yang ke hadapan. This is known as linear ataupun translation. Okay. Tapi ni kan melengkung. This is not straight. Alright. Linear motion can be divided into two. One is known as rectilinear. For example, kita ada satu benda. We push the object like this. It cause the object to move forward. But what happened when we just push the object from one side? It caused the object to still move forward but in a curve. This is known as the second type of linear, curvilinear. Both still lagi translation ataupun linear motion because it change from point A to point B in a straight point. Okay. Contoh kita ada larian, kita berlari, kita tegak, lepas tu tiba-tiba kita ambil lap. Ambil lap, tegak. All this straight part is rectilinear. All this curve part, ni kan curve 1, curve 2, curve 3 is known as curvilinear. Dia still lagi A ke point B. Straight line. Although it is curvilinear lah. Ni kita panggil sebagai translation. Same goes as bola sepak ni tadi. We apply force diagonally, cause the ball to spin. This spin is rotation. So when you see rotation, okay, when we see rotation, this is known as angular motion. When you see a straight line, this is a translation or linear motion. Means that now the total movement of the soccer ball is general motion because it involves a rotational motion and involving a translation. Ni maksud general motion. Oh lama, saya cakap seorang-seorang punya. Okay, again, sorry. Boleh nampak slide putih ni?
Boleh, sir.
Okay. Again, bola sepak. Kena ulang balik lah. Bola sepak. Okay, we apply a diagonal force. It cause the balls to rotate. Dia berputar pada paksinya. When we talk about rotation, it will involve ni, dia mesti ada benda ni. Axis. When you see this one, axis, automatically this motion is rotation. Berputar pada paksi. Rotation is an angular motion. Okay. And then when this ball rotate, at the same time, when we apply force, this rotate, at the same time, this ball is going to move. Selalunya dia akan dapat satu curve ball. Okay, from point A to point B. Ada axis of rotation tak kat sini? Pergerakan ni. Is there any axis of rotation? This one, yes, we have one axis of rotation. Kalau pergerakan curve macam ni, is there any axis of rotation? Ada tak ada? Ada paksi ke tak ada paksi? Come on guys. Ya, meh. Senyap je ni.
Ada.
Mana? When we see this kind of action, this is actually a translation. Translation ataupun linear motion. It does not have any paksi. Tak ada paksi. Bila ada paksi, pergerakan macam ni je. Pergerakan pusing. Macam jam. Okay, pergerakan jarum jam. There are paksi. So, pergerakan ni macam ni je. Jarum jam ni, it cannot move tiba-tiba kat sini. It cannot move tiba-tiba kat sini. Keluar pada paksi. No, tak boleh. So, this jarum jam is angular motion. Tapi the whole jam, boleh tak jam ni bergerak ke depan, ke belakang kalau orang tolak dia? Boleh lah kan, dia boleh pergi sini, dia boleh pergi sana. So, this is point A, this is point B, starting, ending. Bila nampak macam ni, pergerakan begini, change of place, this is translation. So, ini adalah linear motion. Tapi selain ni bukan tegak, lain ni kan bengkok. Okay. Ni yang saya cakap tadi, linear motion, we may have it in two form. One is known as rectilinear, jalan yang lurus. Two is known as curvilinear, jalan yang bengkang-bengkok. Contoh macam ni, bila dia lumba lari kan, dia lari tegak, pengentar desa ke apa, lepas tu dia ambil lap, 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 lepas tu dia lari tegak, dia ambil lap, tegak, ambil lap. Ini pergerakan apa? Linear ke angular? Start, lepas tu dia lari, dia ikut track ni kan, lari, ikut track, habis. Is this one linear or angular motion? Ada paksi tak?
Angular, linear.
Linear. Linear. We have two type of linear. Jadi dekat masa larian lurus ni, this is rectilinear. Bila dia masuk dekat lap, dekat lengkungan, this is known as apa linear? Curvilinear. Bila dia masuk lurus balik, itu rectilinear. Bila dia masuk melengkung balik, itu curvilinear. So linear ada dua, rectilinear, curvilinear. Jadi pergerakan bola ni tadi, we have rotation of the ball, at the same time we have a curve pathway. This is known as general motion. Combination of angular motion, rotation of the ball, and the translation. Itu adalah general motion. Ni dia. Okay, ni dia bagi bola rugby lah. Bola rugby bila kita sepak, it rotates. At the same time, it move forward. So if we see the rugby ball as a whole moving from one point to one point, that is linear motion. But if we include the rotation of the ball, that is angular motion. So we can actually have multiple dimension to analyze. We can analyze the whole motion as linear, or we may analyze the rotation as angular. Ni adalah dua benda yang mempengaruhi motion, and it's known as general motion. Okay. Alright. Okay, so again, linear motion. When we talk about linear motion, it is a motion of translation. Translate ni berubah from point 1 to point 2. Dia berubah tempat. Macam kita berjalan. Bila kita berjalan, kita akan berjalan ke depan ke tepi ke. Means we change place from point A to point B. That is linear motion. But in order for us to move, we need to bend our knee. Nampak? Bend our knee. We need to rotate our hip. We need to have some rotation at our ankle. All of those rotation, bending is is angular motion. Nampak? Gerakan manusia dua. Linear, the whole pergerakan. But in order to have that linear motion, we need to have angular motion. So, combination of those is general. Right. So, linear motion can be divided into two. If the line is straight, it is known as rectilinear. If it is curved, it is known as curvilinear. Okay. Rectilinear and curvilinear. Itu adalah linear motion. When we talk about angular motion, dia kena satu benda. It involve rotation, and when we talk about rotation, it need to have an axis, paksi putaran. If you see a paksi, then that is an angular motion. In other words, human joint movement is angular motion because joint kita bergerak pada paksi. Contohnya, kita ambil kita punya tangan. Okay, we have our tangan. This is your elbow. This is your humerus. This is your radius ulna. Ni kamu punya palm. Okay, kalau kita nak buat bicep curl. Okay, bicep contraction. We try to contract bicep. Means we are going to pull our forearm upwards. Okay. If we try to contract our tricep, we are going to pull our arm backward. Pergerakan dia ke atas ke bawah je. This is an example of rotation. So, at this complex, where is the axis of rotation? Kat mana axis rotation kat sini?
Saya ada lukis ke? Baru nampak.
Tu baru tekan. Okay, dekat sini kan. If we go for bicep contraction, we are going to rotate our hand upwards. If we go for tricep contraction, we are going to rotate our hand downwards. So for this rotation, for this complex, where is the axis of rotation? Humerus ni tangan kita. This one is radius ulna, this one is your palm. Ini elbow. Dekat mana axis? So dia boleh jadi macam ni pergerakan kan. Bicep ataupun dia boleh jadi macam ni. Ni bila tricep pula yang attract. It can be
Elbow.
elbow, yes. Elbow is the axis of rotation. Jadi pergerakan manusia, it always start with angular motion. Jadi ini adalah axis. Automatic, when you see axis and the movement is only rotating, either contract or retract, this is an example of angular motion. Kenapa kita kena tahu? Simple je. Minggu depan kita akan jawab benda tu. Because of different analysis. If we go for angular, the analysis will be angular. If we go for linear, the analysis will be linear. Ni adalah contoh angular. Okay. Alright. Katalah kita tengok pergerakan tangan. Hayun tangan. Okay. Kita hayun tangan. Bila kita hayun tangan, it start from here. And then it become this. And then it become forward like that. Okay. Point 1, point 2, point 3. Alright. Jadi pergerakan ni pergerakan linear ke pergerakan angular? Ayun tangan. This will be elbow. Ni elbow. Tadi elbow je. Is it linear motion ataupun angular motion? Pergerakan menghayun tangan. Linear or angular? Think carefully. Come on guys. Pergerakan ni pergerakan linear ke pergerakan angular? Menghayun tangan. Swing your arm. Try to swing your arm. Okay, tengok tangan kamu tu and then determine. Is it angular or is it linear motion? Translation ke rotation? Yang mana?
Rotation.
Rotation. Jadi kat mana axis dia?
Shoulder.
Shoulder. Yes, that's true. Tu angular motion. Okay. Bila kita berjalan, tangan kita berhayun tak?
Hayun.
Hayun kan? Okay, bila kita berjalan ke depan, kita tengok pergerakan perjalanan, bergerak tu sendiri sebagai satu pergerakan. Linear ke angular? Kamu daripada dapur pergi ke hall, that is walking. Berjalan. Tu linear ke angular?
Linear.
Linear. True. That is true. So, when you walk from your living room to the kitchen, are you going to swing your arm?
Yes.
Yes. Jadi, bila kita berjalan, this is what we call when human execute an action, it is actually general. Why? The action itself, the whole action is linear. But in order to get that linear, there will be angular. Kalau kamu tak percaya lagi sekali, you try to do this. If someone able to show me, you can actually move forward linearly, just linear. Saya tak nak general. Okay, linearly, saya akan paskan kamu. Dapat A, tak payah buat apa-apa assignment, tak payah buat apa-apa kerja, tak payah datang kelas kita. I'm going to give you an A. But you need to prove to me, move forward without any movement at any given joint. Boleh tak boleh? Nak try boleh try. Kamu boleh cuba bangun sekejap, kan? Bangun berdiri and try to move maybe a step or two forward. Just a step or two. Without any bending of your body parts. Tak nak bend dekat lutut, tak nak bend dekat peha, tak nak bend dekat ankle, tak nak bend dekat mana pun. Because I only need linear motion. When you bend, that is angular. So the motion will become general. So I need only linear. Can you do that? Boleh tak? Cuba try.
Tak
Macam
boleh
penguin.
ke?
Kenapa tak boleh? Lulus tanpa sebab tanpa usaha. Usaha untuk bergerak ke depan. Even if you go for roller skating pun, kamu akan ada angular motion dekat roda. Okay, so there are no way for you to actually move linearly. It's still going to be general lah. Tu general. Combination of linear and angular. And that is the meaning of this one. Okay. Ni, page yang mula-mula ni apa? Most human movement is complex combination of both because it is actually useful to break. Barulah kita boleh buat analisis yang pelbagai. We can go for linear analysis, we can go for angular analysis. So human motion is general combination of linear motion, okay, this one rectilinear and curvilinear, and also angular motion, which is rotation at an axis. Kalau sakit kepala sangat, aduh, axis kat badan manusia kat mana? Joint. Semua joint tu ialah axis. Okay, all of the joint you have in your body is axis of rotation. So all the movement occurs at that particular part is angular motion. Okay, sampai situ. Ada soalan? Any question?
No, sir.
Okay, kalau tak ada, kita sambung dengan pergerakan yang saya rasa this is the the last type of movement based on these notes. Okay, it is regarding projectile. Okay, so in the universe, basically in Earth, most of human movement, especially spotting movement, is actually involving projectile. Okay, so before we go further, we need to know what is actually a projectile. Apa benda yang kita boleh panggil sebagai projectile? Okay, before we go further, projectile is Angry Bird. Kalau lupa lah, ingat tu je. You have a sling, you have rat, si merah tu, and then you have the pig. Okay, apa yang ada lagi? Bila kita nak lepaskan, kamu pernah main game ni tak?
Pernah.
Nampak mesti dia ada benda macam ni kan bila kita nak lepaskan kan?
Betul.
Okay, ingat benda ni je. Projectile involve thing that fly. And involve ni, natang ni. This is known as trajectory. Ataupun projection pathway. Kalau ini projection pathway, automatically ini projectile. Okay, apa itu projectile? Projectile is a free body diagram. Selalu nanti kamu akan jumpa term ni. Free body diagram. Okay, a free body diagram is actually any object which subjected to several properties. One, it's subjected to external force. Two, it's subjected to gravity. And three, it is subjected to friction. Ataupun kadang-kadang nama lain dia air resistance. Dia subject pada tiga benda ni. Maksudnya, it does not have its own force. Macam this Angry Bird. The external force caused by slingshot. This is the cause of force, which make the birds travel forward. Bila dia travel, dia akan jatuh ke bawah. Dia akan sampai satu tahap, puncak dia, apex, and it will start falling down. It is due to gravitation. Okay, so when we talk about projectile, it is a free body diagram subjected only to external force, friction and gravity. Example kita ambil dalam sukan, bola sepak, kena sepak, bola tu travel. This is a projectile. Okay. Apa lagi? Bola netball. Okay, passing bola netball pada point A to point B. This is a projectile. Okay, tapi projectile ada trajectory. Trajectory kan something yang macam ni. Ni tak sama. Okay. When we talk about projectile, trajectory je. Kita cerita trajectory dia je. Okay, take a look closely. When we talk about this trajectory, it involves two component. Satu, ni, ke sana, melintang. This is known as horizontal component. Okay, yang kedua, kita kena cari apex dia. Mana bahagian paling tinggi? Sini. So, from the base of the projection to the apex of projection, this is known as vertical component. Ini puncak ni kita panggil dia sebagai apex. So, a trajectory consists of these three things. Dia akan ada apex, dia akan ada vertical component, dia akan ada horizontal component. Okay. So, kalau projection kita macam ni, ada tak horizontal component? Yes. Katalah ni start dia, ni end dia. Okay, horizontal component is from start to end lah. Ni daripada bawah start ni ke hadapan. This is horizontal component. Ada vertical tak? Ada. Kalau ni start dia, ni yang paling tinggi. So, it start here. This is the vertical component. Ada apex tak? Yes. This is the apex. So, this is a trajectory. Okay, katalah dia buat macam ni pula. Dia start pada bawah ni. Dia pukul bola dia naik atas. Zoom naik atas. Lepas tu bola tu turun balik. Ending. Ada horizontal component tak dekat sini? Is there any horizontal component?
Ada.
Ada. Pendek je kan? Horizontal component. Vertical ada tak? Tinggi kan?
Ada.
Ada vertical component. Ada apex. Dia pun trajectory. Tapi yang ini kita panggil sebagai vertical trajectory. Pasal dia lebih vertically instead compared to horizontal. This one we call it as horizontal trajectory. So in any movement basically it is actually a projectile. Kita main frisbee, we go for frisbee throw kan. Pergi depan. Lepas tu orang tangkap. Mungkin kita nampak the discus travel in a straight line, but if you go for a very high speed camera and we capture the image of those discus flying, you're going to see something like this. Nampak? Macam tu. Ada horizontal component tak kat sini?
Ada.
Ada. Dia start mungkin kat sini lah kan? Sampai sana. Horizontal component. Ada vertical? Ada. Vertical, horizontal. And this is the highest point. So this is the apex. This is a trajectory. Trajectory jenis apa? Horizontal ke vertical yang ni?
Horizontal.
Horizontal. Jadi when you know thing like this, anything that involve a free body diagram, benda yang dibaling, dipukul, ditendang, all those that does not contain its own force will actually fall under projectile. Dia akan jatuh under projectile because it is a free body diagram and it has its own trajectory or pathway. So that is projectile. Okay, kapal terbang. Kapal terbang. Lepas tu dia naik. Lepas tu dia turun. Is it a projectile? Kapal terbang projectile?
Tak.
Kenapa? Sebab dia satu je. Kenapa? Free.
Sebab kedudukan dia tak statik.
Bukan,
Gerak
bukan. Bukan kedudukan. Tengok balik. Free body diagram. Saya bagi clue sikit. Free body
Sebab dia
diagram.
tak ada external force.
Ya, sebab dia tidak memerlukan external force to fly. It has its own and engine. It can change pathway. Bila free body diagram, whenever the object had been released, it cannot change the pathway. It may bang, it may go to the left, it may go to the right, but it will always start here and ends dekat satu bawah. Ni projectile. Kalau bola ni sampai sini, lepas tu dia boleh naik balik ke atas, this is not a projectile because it has its own means or its own force to change the pathway. Kalau kapal terbang ni, kita buang enjin dia. Dia gliding je. Okay, dia gliding. Katalah dia start sini kan kapal terbang. Dia glide. Berhenti. Gliding. Is it a projectile?
Yes.
Yes. Yes. Because it does not have its own force. It's still subjected to, kenapa dia ke bawah? Gravity. It's still subjected to air resistance. It's still subjected to external force. EF. External force. Jadi, kena ada 3 benda ni. Baru kita boleh cakap dia projectile. Okay, manusia terjun payung. Okay, manusia buat parachuting. Is it a projectile?
Yes.
Yes. Walaupun dia terbang tak mengarut kan. Pak sampai sini. Again, it's still subjected to only gravity, external force. It does not have force on its own and then resistance. Okay, kalau kata manusia yang pakai payung terjun ni, kita add on satu benda. Kita add on kat belakang dia, kipas, paragliding. Rotate. Now, it can change direction on its own. Is it a projectile?
No.
No, because there are force. Ada je benda ni, internally, it is not a projectile. Because projectile is involving a free body diagram. Free body does not contain force on its own. Tu je. Nak ingat, nak tahu tu senang. Melontar lembing, javelin throw, is it a projectile?
Yes.
Yes. Apa lagi? Membaling pinggan kepada boyfriend. Zaz. Projectile tak?
Yeah.
Iya. Apa lagi? Gaduh dengan boyfriend, tumbuk dia, gigi dia tercabut. Fly away out of the mouth. Is it a projectile?
Yes.
Mana dia punya sumber tenaga dekat situ? Where is the...
Tu tangan.
Tu tangan. Yes, betul. That is a projectile. So whenever you see an object which only involve these 3 things, okay, automatically kamu kena ingat this is free body diagram. Projectile. Okay, projectile. So in your level you don't need to go in depth lah, but projectile basically most of our equation, most of sporting performance is actually to solve projectile case. Okay, to solve this one. Alright. So in projectile, empat dia cakap ni. Okay, basketball, discus, depending on the projectile, different kinematic quantities of interest. Kita tak apa. In projectile, we have 2 component. We have discussed this one. Vertical component, komponen menegak, and horizontal component, komponen melintang. Okay, we have these 2 component of interest. Ni dia. Okay. Horizontal is this one, vertical is this one. Ni kalau siapa-siapa nak buat nak buat experiment, you may have some a simple experiment like this. Start from what we call it, from the same height. Okay, start from same height. Just release the ball. Another one, toss the ball forward. You're going to notice that these 2 balls actually contact at the same time. Okay, contact to the floor at the same time. Although yang ni ke depan, yang ni tidak. It is because at any given point of a projectile, at any given point of this, okay, bila kita buat benda macam ni kan, dekat mana-mana point pun dekat sini, value ni takkan pernah berubah. Acceleration. And this make everything touch the ground at the same period of time. Ni kalau nak buat eksperimen, boleh buat kat rumah. Okay. Mungkin lepaskan pada ketinggian 1.5 meter ke bawah and 1.5 meter ke depan. You are going to notice both of the ball going to contact the land at the same time. Okay. Because of at that point of time, the gravity force is equal. Okay. For projectile, ini dia bagi tahu apex semua yang tempat-tempat tadilah we have cover this one. For projectile, there are 3 factor which influencing the range of motion. Okay. Bila kita cerita projectile ni sahaja, katalah kita ambil bola sepak tadi. Okay. How far it can go ataupun horizontal component ni. This component, there are 3 properties which influence horizontal component ataupun dia punya range. Okay. Number 1 is the angle of projection. Bila kita cerita projectile, dia akan ada angle ni kan, melengkung ni. So what is the angle here? Ataupun kita namakan dia sebagai macam ni, telur slash, nama kampung dia theta. What is the angle? Number 2 is the speed of projection. Berapa speed ni? Bola ni kena sepak. Berapa velocity dia? X meter per second. So lagi besar X, lagi besar velocity, lagi jauh lah dia akan pergi kalau theta dia sama. And number 3 that play a major role in determining range is the relative projection height. Okay, so let's go to the first one. Angle dulu, theta. Okay, pasal kita nak cerita yang pertama ni, kita ada kaitan dengan yang ketiga, relative projection height. Okay. In physics, it has been proven that kalau projection kamu projection yang macam ni. Okay. Projection yang mana starting point and ending point is at a similar level. Ini kita panggil sebagai relative projection height equals to 0. Okay, relative projection height ni is actually the difference between the height of start and the height of end. Contoh macam bola sepak macam ni lah. RPH dia kosong because padang bola mana ada lekuk-lekuk kan. Katalah kita tengok basketball pula, basketball. So, usually player nak baling bola, basket dia tinggi, betul? Dia nak baling macam ni. Kalau macam ni, dia kena baling macam ni lah. Naik atas, masuk. Okay. This is what we call RPH negative. Negatif 1 ke, negatif 2 ke. The difference between starting dengan ending. Kalau starting dia rendah, ending dia tinggi, RPH dia negatif. Okay. Kalau macam kita tengok golf pula, golfer. Tee off. Okay, dia tee kat atas. Dia punya hole kat bawah, green dia. So, dia akan tee macam ni. This is what we call relative projection height positive. Because it start higher compared to ending. Jadi, untuk relative projection height is the difference between starting and ending of the projectile. If the starting is equal in terms of height with the ending, relative projection height dia kosong. Starting sama dengan ending. Kalau starting is lower than the ending, relative projection height dia negative. And if the starting point higher compared to the ending point, relative projection height dia positive. Okay, why we need to know all these 3 things? Simple. It is proven that if RPH equals to 0, the recommended theta equals to 45 degree in order to get the longest range. Tapi kalau dalam case macam ni, RPH negative, the recommended theta is actually more than 45 degree. So yang ni lawan dia lah. For RPH positive, the recommended theta is less than 45. Less sama dengan less than 45. Kalau kat sini kita bagi 45 apa jadi? Dia jadi macam ni. 45. Tak sampai. Kalau yang ini kita bagi 45 apa jadi? 45. Tak sampai. And that is the reason why we need to know RPH. Okay, barulah kita boleh determine the recommended angle in order to execute the action. Okay, so in RPH equals to 0, 45 is the best angle. Jadi saya tunjuk kenapa. But not to RPH negative and RPH positive. Ini adalah dua benda yang mempengaruhi range of projection. Okay, angle and relative projection height. So now, if the angle is equal, barulah velocity mempengaruhi projection range. Kalau angle ni semua 45, okay, setelah kita ada dua case. Okay, angle 45. Case 1. Case 2, angle 45. Tapi case 1 velocity dia 100 meter per saat. Case 2 velocity dia 50 meter per saat. So 100 akan pergi double compare to 50. If the angle is equal, and then only the speed of projection play a major role in determining how far the projectile can go. So itu adalah 3 properties which play a major role in determining flight pathway. Angle of projection, this one, theta. Projection speed, what is the initial speed of the projectile, and the relative projection height, the height between start and end point of the projection. Okay, so kita tengok ni. Okay, this is angle of projection. Direction at which a body is projected. Change in projection speed infers the size of trajectory, but trajectory shape is solely dependent on angle. Okay. Ni jenis projection yang tadi. Okay, kita ada oblique, kita ada horizontal, kita ada vertical trajectory. Although the shape is quite different, it still involve all those 3 things. Oblique, horizontal component, vertical component, apex. Horizontal, we have horizontal component, we have vertical component, and apex. Same goes as vertical. We have vertical component, apex, and horizontal component yang pendek. So, regardless of the shape, all those will actually have those 3 properties. Vertical, horizontal, and the apex. Okay, ni contoh. Ada tunjuk angle je, angle, ni. Okay, tak nampak. Okay, dia tak tunjuk angle. Kita tengok, okay, pada graf ni. Can you see graf ni dia ada by pair. Okay, ni pair yang pertama. 1, 2. Nampak tak? Ni pair yang kedua. 1, 2. Can you see this one? Ni pair ketiga.
Nampak.
Ni pair keempat. Ni 1, 2. Dan 1 ni dia jatuh belakang sekali. 1 je tak ada pair. Okay. So, what does this graph try to show you is the angle. Okay, the angle. And the longest one is actually 45 degree. Okay. So, mana dia buat ni? Dia buat ni. Kita tengok sini. If the projection speed is equal and we change the angle, 10 degree, kita akan dapat range 3.49. Same as 80 degree. Angle terlalu kecil, angle terlalu besar. This one. Ni. 10 degree. Okay, the first one. Yang paling besar sekali ni, 80 degree. It serve the same range. Lepas tu kita ada 20 degree dengan 70. Lepas tu kita ada 30 degree dengan 60. Lepas tu kita ada 40 degree dengan 50. And then kita ada 45 degree. Which give you the most outcome. Okay, which is giving you the most outcome. Jadi saya tunjuk kenapa. But if the RPH is 0, it is 45 to get the most outcome. Ni dia punya perumpamaan lah. Okay. Ni nota berkenaan dengan relative projection height. If start and end at the same level, RPH 0. If you start higher compared to ending, RPH positive. If you start lower compared to ending, RPH negative. Jadi berapa RPH we need to determine, we need to measure sebenarnya berapa beza antara starting dengan ending in term of meter. That will be the figures of the RPH. Okay. Ni relative projection height. If RPH 0, 45 degree. If RPH RPH positive less than 45, ni macam golfer tadi tu. If RPH negative less, it will be more than 45. Ni macam basketball. Okay, basketball, netball, where the ending is higher. Alright. Okay, now I'm going to show you why 45 degree. Okay, this is just for your knowledge. Sampai tadi dulu, sampai projectile. Can you get it? Are you okay with that?
Yes.
3 faktor. Okay, projectile involving free body diagram, involving projection, trajectory ataupun projection pathway, which has vertical component, horizontal component, and also apex. Mesti ada 3 benda tu. And 3 factor influencing projectile, we have speed, we have angle, we have relative projection height. Okay, now I'm going to show you why 45 degree is the best. Okay, so in the projectile, okay, kita ada horizontal, kita ada vertical. And in any projectile, we can divide this trajectory into 2 parts. 2 trigonometry. Kita boleh bahagikan dia. Okay. Apex. So from start to apex, this is known as the up portion. And from apex to end, this is known as down portion. Okay. To measure how far a projectile able to go, there are simple equation. Okay, range equals to V cos theta time. Okay, ni dia punya formula dia. V cos theta time. Okay, ini untuk pengetahuan kamu saja. Nanti kita tengok kenapa. Itu je saya nak tahu. Yang saya perlu kamu tahu. Okay, and this time is the time taken for the projection to go up and to get back down. Maksudnya up portion dengan down portion. Jadi untuk up portion ni, untuk time, kita akan guna formula macam ni. T equals to V sin theta over G. For down portion pun benda yang sama. V sin theta over G. Jadi kalau T yang keseluruhan, dia ialah V cos theta, V sin theta over G tambah V sin theta over G, resulting 2V sin theta over G. Dia macam ni. Okay, kalau kita darab masuk semua ni, yang ni matematik sekolah dulu, kamu akan dapat V square, V dengan V. Okay, lepas tu kita ada 2 sin theta cos theta over G. Bahagian ini, kalau kita mudahkan, dia akan jadi sin 2 theta. Jadi kalau kita masukkan balik, kamu akan dapat formula macam ni. R equals to V square sin 2 theta over G. Ini untuk kita cari range. Okay. And the note said that in order to get the longest range, the angle here, if RPH 0 is 45 degree. Maksudnya theta dekat sini 45 degree. Okay, kenapa? R equals to V square sin 2 theta over G. Okay. Sekarang kita tengok contoh Kita tahu G 9.81. Katalah bola tadi kita sepak dia. Kita sepak bola tu dengan kelajuan 10 meter per saat. Okay. Kita ambil ni. Kita cuba selesaikan ni. Sekejap Okay. Kita cuba selesaikan sin 2 theta saja. Alright. So in trigonometry, especially in sin kan, value yang saya cuba dapatkan, saya nak sin, figure saya tak tahu, the largest value is 1. Largest value sin tu 1 saya nak. So, the largest value of sin is 90. Sin 90. Value dia 1. So, if sin 90 equals to 1. Okay. Ni tengok. Kalau 2 theta sama dengan 90, theta sama dengan berapa? 90 bahagi 2.
2.
45. Now, let's try. Kita tukarkan semua ni dalam equation. Okay, kita ambil theta 45. Later on, kita ambil theta lebih daripada 45 pula. Okay, tengok R equals to V square. V kita ambil tadi 10 square sin 2 kali 45 bahagi dengan 9.81. Okay, cuba selesaikan. Berapa dapat? 10 kuasa 2, 100. Sin 2 kali 45. 2 kali 45 sama dengan 90. 2 kali 5 pula. 2 kali 45 sama dengan 90. We go to sin, kita dapat 1. Bahagi dengan 9.81. Okay, 100 bahagi 9.81. 10.19 meter. Okay, now let's play around with the figures of theta. Okay, G equal to 9.81. V equals to 10. Theta kita tukar. Tadi kita guna theta 45. Now let's try theta lebih besar. Theta 70. So R equals to V square sin 2 theta over G. Cuba main dengan ni. Dapat apa? 10 kuasa 2 sin 2 kali 70 bahagi 9.81. We have 100. 2 kali 70, 140 sin 0.64. 0.64 9.81. 0.64 kali dengan 100 bahagi dengan 9.81. 6.55 meter. Okay, now let's change theta dia kepada nombor lain. Kita change theta lagi besar. Kita change theta 125 degree. Okay, R equals to V square sin 2 theta over G equals to 10 square sin 2 times 125 over 9.81 equals to 100. Okay, 2 kali 125 sin negatif 0.9. Okay, kita neglectkan negatif dia. Bagi 9.81. Okay, 100 kali 0.9 bahagi 9.81. 111. Kat mana saya silap ni? Oh, 0.81. Sorry, terbalik. 9.81 kali 0.9. Okay, bahagi 9.81. Wow, betul lah. 9.17 meter. Any numbers which is greater than 45 ni, kamu takkan dapat dah. This is the highest. Because when we go for sin 2 times theta 45, kita akan dapat jawapan 1. That is the largest multiplication that can be done. So other than that, you're going to end up dengan numbers less than 1. Jadi you are not going to have the longest distance. And this prove that if RPH equals to 0, the recommended theta is actually 45 degree in order to get the longest range. Proven. Okay, proven. Ini cara untuk kita prove lah. Okay, how we want to prove that 45 degree is the best angle. Okay, dia dah bagi, cuma sini saya nak tunjuk kamu play around with the numbers and then you can see first hand what is going to happen if we change the numbers to less or more than 45.